Okay, so today we talked about the converse of the Pythagorean theorem, and it says use the converse of the Pythagorean theorem to classify triangles is what we're going to do today. So the converse, if you remember, converse just means I take the hypothesis of my statement and switch it with the conclusion. Okay, so it says if the square of the lengths of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So basically what it's saying is if c squared is equal to a squared plus b squared, remember that's our Pythagorean theorem, then we can say it's a right triangle. So using it the opposite direction today, we're using the measures to prove what type of triangle it is. Okay, so on the first one it says, is triangle ABC a right triangle? Okay, now I can't just look at it and assume, hey, it looks like a right angle. I have to actually prove it. Okay, so the longest side is still going to be our c squared. Okay, so I'm going to start by saying 12 squared plus 16 squared is equal to 20 squared. 12 squared would give me 144 plus 16 squared is 256 equal to 400. Okay, if I take 144 and add it to 256, it gives me 400. I know that's kind of hard to see. Okay, so it gives me 400. So now I have 400 equal to 400. Since these two are equal to each other, I say, yes, it's a right triangle. Okay, so when I test down here, same idea. My side lengths are 11, 8, and 14. 14 has to go at the end because it's the longest. Doesn't matter which order I do these two. So 11 squared plus 8 squared equal to 14 squared. I'm really testing to see if they're equal. 11 squared gives me 121. 8 squared is 64. 14 squared gives me 196. If I add these two together, I get 185 equal to 196. They're definitely not equal, so I say, no, it's not a right triangle. If I explain my reasoning, I can say a squared plus b squared does not equal c squared. Okay, this one right here, what I would do is I would type in the square root of 39 just to get an idea of the measure, and it says it's about 6.2. Okay, so now if I look at my side lengths, 6.2, 5, and 8, 8's still the largest, so it has to go at the end. When I actually calculate, I need to use the square root there. So the square root of 39 squared plus 5 squared equal to 8 squared. If I do the square root of 39, and then I square it, I end up with just 39. Okay, because the square root and the square are inverse functions. They're kind of opposites of each other. So 39 plus 25 is equal to 64. If I add these two together, I'm going to end up with 64 equal to 64. Since they come out equal, I would say, yes, it's a right triangle. If they ask me to explain it, I could just say a squared plus b squared equals c squared. Okay, the last one, once again, I put the longest number at the end. So I say 20 squared plus 21 squared equal to 29 squared. Here I get 400 plus, I believe 21 squared is 441. And then 29 squared gives me 841. If I add those together, I'm going to get 841 equal to 841. Is it a right triangle? I would say yes. And then my reason is just a squared plus b squared equals c squared. Okay, now sometimes when they don't come out equal, we want to know what type of triangle it is because we know it's not going to be right. So what we're going to use is these Pythagorean inequalities. It says if I plug in the values and a squared plus b squared is greater than c squared, then the triangle is going to be acute. Okay, we already talked about if it's equal to each other, then it's right. The last one says if a squared plus b squared is less than c squared, then we know it's going to be obtuse. So we're going to do the same work in testing. Okay, so down here, 2, 5, and 6. 6 is the longest. I'm going to put that at the end. So I'm going to say 2 squared plus 5 squared is equal to 6 squared. 2 squared, 2 times 2 gives me 4, plus 5 squared is 25, equal to 36. If I add those two together, I get 29 is not equal to 36. I know that 36 is bigger. Okay, so 29 is less than 36. If I go back and look at my inequalities, if that last number is the largest, it has to be obtuse. Okay, taking a look at the next one, I have 8, 15, and 17. 17 is the longest. It's going to go at the end. So 8 squared plus 15 squared equal to 17 squared. 8 squared gives me 64. 15 squared is 225. 17 squared is 289, I think. Yep. If I add those two together, I get 289 equal to 289. What type of triangle is it? It's going to be a right triangle because they're equal. Okay? The last one, 7, 7, and 7, we've actually covered this in class before. This would be equilateral. If it's equilateral, we know it's equiangular. And if I were to take that measure of the triangle and divide by 3, I get 60. Okay? So that's prior knowledge. We know this triangle is going to be acute. But if we test it like we did today, we would just say 7 squared plus 7 squared equal to 7 squared. Give me 49 plus 49 equal to 49. If I add 49 and 49, I get 98 equal to 49. I know they're not equal. 98 is really greater than 49. And once again, if that side is greater than the leg squared, then we say it is acute, which is what we found. Okay? The only difference between these problems here and these ones here is now I don't have a diagram. They're just giving me the 3 side lengths. I always put the longest at the end. Okay? So this is going to be 7 squared plus 24 squared equals 24 squared. 7 squared gives me 49. 24 squared is going to give me 576. If I add these two together, I get 625, which is bigger than 576. What type of triangle is it? Has to be acute. Okay, test the next one. 7 squared plus 24 squared equal to 25 squared. Well, the 7 squared and the 24 squared actually repeats from the previous problem, so I know these two together are going to be 625. If I do 25 squared, I also end up with 625, and since they're equal, I would say this triangle is a right triangle. Okay, the last one, 7 squared plus 24 squared equal to 26 squared. Looks like they're repeating those first two values just like the last two problems. So I'm just going to put 625 here. When we added the two squares, we got 625. If I go 26 squared, I end up with 676, while 625 is less than 676. This triangle is going to be obtuse. Okay, worksheet for today. So you are looking for worksheet number 5, which is section 4.5 on Google Classroom.